Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.9. Read the scenario, determine the voltage across each diode in given below figure assuming an ideal model. In this figure, a diode is connected in 4 different circuit configurations and we have to find voltage across this diode in each configuration while considering the ideal model of diode. So we will start from this first configuration. In this configuration, a diode is connected between two voltage sources through a resistance. So positive 5 volt is appearing across the anode of the diode while positive 8 volt is appearing across the cathode of the diode. Anode voltage is lower than cathode voltage, so we can say that this diode will be in reverse biased mode, and in reverse biased mode diode never conduct. So voltage across this diode will be equal to the difference of these two voltages, plus 5 volt minus 8 volt, it will become minus 3 volt. So this diode will be having minus 3 volt across it. Move to next configuration. In this configuration, a diode is connected through a resistance to a voltage source. Positive terminal of voltage source is connected to the anode of the diode while negative terminal of voltage source is connected to the cathode of the diode. And because this is an ideal diode, so it will have no potential barrier. Potential difference of voltage source is 100 volt, so this diode will be in conducting mode because the potential barrier of the diode is much lower than the potential difference of voltage source. So we can say that this diode will acting as a short circuit and it will have no voltage across it because of the ideal model of diode. So voltage across this diode will be 0. Move to the next configuration. In this configuration, a diode is connected across a voltage divider network through a resistance. So first we have to find voltage across this 4.7 kilo ohm resistance. Later on we will be able to find out voltage across this diode model. In order to find voltage across this resistance, we will omit this resistance and diode for now. The circuit will become simple voltage divider network. Now we have to apply voltage divider rule to find out voltage across this 4.7 kilo ohm resistance. That will be equal to 4.7 kilo ohm multiplied by 30 volt divided by the sum of all series connected resistances. Solve this equation to find out voltage across 4.7 kilo ohm resistance. That will become 19.58 volt with positive terminal here and negative terminal here. After calculating the voltage value across this resistance, this same voltage will be appearing across this resistance and diode model because of parallel connection. So positive terminal of this voltage source is connected to the anode of the diode while negative terminal of this voltage source is connected to the cathode of the diode. So the diode will be in conducting or forward biased mode, and we know that in case of ideal model of diode, we have no drop across its terminal. So this diode will be having 0 volt across it. Move to the last configuration. In this configuration, this diode is in reverse biased mode due to this voltage source because positive terminal of voltage source is connected to the cathode of the diode and negative terminal of voltage source is connected to the anode of the diode. But in right half circuit, the positive terminal of voltage source is connected to the anode of the diode and negative terminal is connected to the cathode of the diode. So in this manner, this diode will be in conducting or forward biased mode, and because of an ideal model of this diode will having no potential barrier or no voltage drop across it. So voltage across this diode will be equal to 0 volt. This was all about chapter 2 exercise problem number 2.9. Thank you. See you again in next video.